Okay, thank you. So, good morning, everyone. It's my pleasure to present our work in this conference. I'm Fabiola, research professor from Brazil, and our work is about evaluation without ground truth, a comparative study on preference mining techniques in Twitter social network. This is a position paper so we have some preliminary results. First of all, as motivation, imagine that a user is expressing his preference about what he likes to read. In a first moment, he says, "Oh, I don't like sports. I don't like to read sports news." In the next moment, he can say, "I love politics. I read everything about it." But then, in another moment, he says, "Actually, I'm curious about the Olympic Games. Today, I feel like reading about sports." So, user preferences are changing all the time. And basically, social networks can help us on understanding these preferences. We can find many sources where we can look for preferences, users' preference, and social networks can be a good source from that. For that. To understand user preference for social networks, looks promise. And basically, the motivation, why we study user preference is that once we know this preference, we have a lot of applications like, for example, personalization, recommendation systems, or search engines. Um, uh, and basically, in social media research, evaluation without ground truth is a pressing need. We look for patterns that describe preference of a given social network user. So, for instance, considering a domain of news, we want to discover what are the user you preferred claims through their interactions in her social network. We can discover that, for instance, you prefer to read news about politics over sports news, for example. And talking more about the user mining, preference mining problem, here we have the schema of a traditional preference prediction system. Basically, according to some feedback, we are able to elicit and mine some preference. The final goal is to build a prediction model which returns a preference order or a ranking. Given that schema, our problem definition is that given a preference domain and a social network, we need to return a set P of order relations over some domain D that describes the user's preference. And our problem is how to decide if these preferences are really the user's preference, because we don't have a ground truth set. So basically, to investigate this problem, we then collect some data from Twitter social network. And here we have some statistics of our network. We basically tracked all mentions to a Brazilian newspaper Twitter account via Twitter streaming API during around 3 months. And for each tweet, we assigned a topic related to politics, international sports, entertainment, security, economy, and others. So basically, we manually assigned these topics after some topic modeling using LDA algorithm. And here are our statistics around 1,700,000 tweets. Also have defined our problem and our data set. Here,
Sorry, excuse me. I don't see your presentation.
oh, really? Here I'm going through the slides, and I was talking about, so here's the schema of a traditional preference prediction system, and here is the Twitter dataset statistics that I've mentioned about. And now I'm talking about also have defined our problem and our dataset. Here there is our proposal to mine user preferences from Twitter. And basically, we compare two literary methods for preference mining based on implicit feedback. The first one is the follower network approach. The second, topic distribution. And we compare the baseline with the baseline method given by explicit feedback, which are the favorites. Talking about the explicit feedback, which is based on favorites, we know that intuitively we can build a preference ranking based on the number of favorites, of likes a user gives over a topic in preference domain. Apparently straightforward, this method is still faced to a lack of ground from problem, as users not necessarily assign as favorite their preferred topics. Sometimes favorite can be just a strategy to start some important post, which not necessarily is preferred. The second approach, the second strategy is based on the following follower relationship. And the intuition is that if a user follows some personalities or celebrities, then user prefer topics related to what those personalities represent. So, for instance, if a user follows some representative celebrity, YouTube from fashion world, then U1 does not follow U3, which is a religious leader. Then we have that U1 prefers fashion topics over religion topics. So that's the second strategy that which we call follower network. And the third strategy is also an implicit feedback based on topic distribution. Basically, the preference mine strategy is based on the number of tweets about some topic in our domain. So the most tweeted or retweeted topic by some user is the preferred one over the second most retweeted, which is preferred over the third one, and so on. So for instance, if some user posts 3 times about politics and 2 times about sports, then we can establish a preference order between politics and sports. So user 1 prefers politics than sports. And basically, preference order levels can be deeper than the previous strategy, which was the follower network method. And here we have some preliminary findings. And basically, our question, we seek to answer how the methods favorites, follower network, and topic distribution overlap. And so we propose an agreement score for a given user, where the result preference set is mined by some method. And basically, we have a set of methods, and we can combine them. So the higher our agreement score is, the higher the agreement among the methods, and thus more reliable is the resultant preference ground truth set. And basically here we have some, for a random user, we have computed the agreement scores among all 3 methods for a random user U1 from our data set. On the left, defined preference set according to each strategy, and in the right we have the results, and basically the best combination is the second one, which combines favorites and topic distribution strategy just for one user. So we aggregate our results for all users for our entire data set, and the best results, the best combination is again the favorite plus topic distribution strategy, where we got the higher score, agreement score. So, as final remarks, we have raised a discussion about the evaluation without ground truth in social networks. Three different methods have been implemented considering a common domain, which was the news topic. We have proposed a combination strategy to generate a final trustworthy set of user preference. And as next steps, we will be studying more methods and more social networks. And our final goal is to propose a framework able to extract preferences based on correlation or causality patterns to eliminate the need of ground truth sets of preference relations. And okay, thank you for your attention.
I have, of course, one question about data set. Where you find the data set which you are using to train your model and define dependencies in preferences model you are presenting?
Basically, we collected from a Twitter account from a Brazilian newspaper, and we collected the data tracking around 3 months with Twitter streaming API. So we've built our own data set.
If your newspapers have some REST API interfaces to collect this data to your application?
Actually, we don't have any interface to collect the data.
So you have done this manually. So you collect the data and put to your model, I suppose. Yes.
Yeah. Basically, it was hard manually work. Yeah.
Okay. Thank you very much. Is there any more question? Janusz, please ask the question.
I don't have question, but I would like to congratulate Fabiola take part in our presentation, in our session, because in Brazil now is, I think, 2 a.m.
Yeah.
Overnight. Yeah.
Yeah, actually, it's 4 a.m. Yeah.
Thank you very much.
No problem.
This is virtual applause from me. Okay, I don't know, maybe you see. Thank you very much once more for the very interesting presentation.